My name is Emily Hoon, and I serve as the Global Industry Manager for Water, Wastewater, and Waste at Endress Hauser. Our company is headquartered in Switzerland and is a global leader in process measurement and automation, dedicated to advancing innovation, digital transformation services, and solutions. I have the privilege of leading the water strategy and ensuring that our offering remains competitive, as well as collaborating with stakeholders from all around the world in overcoming the challenges of the water cycle and by providing high quality, precise, and reliable measuring technologies. So our presence at the summit actually underscores our position as a committed and influential player in the global water sector. Not just me, but my colleagues are looking forward to interesting and engaging sessions, particularly around the megatrends, future of desalination and water reuse, the role of AI in water, as well as the priority industries for growth. The inputs that we get from key players in the market, the industry leaders, give us a fresh perspective on some of the issues that we're working on within the company. And their opinions and perspectives are actually a reinforcement of the business. So that's giving us firstly an assurance and a reinforcement. And secondly, the perspectives can be quite refreshing. So last year at your Global Water Summit in London, you had Pure Control, and Pure Control won an award for innovation. And this has actually sparked some eye-opening comments within my colleagues on where this is going to take us. We contribute to this sector by providing high precision measurement like flow meters, quality analysis sensors, level pressure devices, as well as temperature sensors. And combined with digital technologies embedded in services and solutions, we can enhance the efficiency of, for instance, membrane filtration treatment processes. So as far as the operator is concerned, OPEX can be reduced. For example, when fouling or scaling of the filtration or reverse osmosis membranes can then be detected, thus optimizing cleaning circles or cycles and prolonging the lifespan of these membranes. Traditionally, when we think about sludge treatment, it is dealing with the sludge, dewatering it, making the volume as small as possible so that the transportation of what's left of the sludge is the cost involved is then is minimized, and that's it. It's either then incinerated and then used as whatever building blocks for cement or even landfill. But I think the technology is going to level up on the sludge treatment process. Also, legislation are going to be stricter in the next 5 to 10 years. So we see quite a big shift already from sludge to biogas creation. This has been happening for the last 10, 15 years. But right now from biogas to biomethane, and who knows what's going to happen next. We also see mono-incineration, where sludge is pre-treated within the facility of the wastewater treatment and then incinerated, producing the ash, and phosphorus is recovered on site in the wastewater facility. So this is an exciting new advancement that we are seeing coming up in various parts of the world today. I think Switzerland and parts of Germany are leading the way and have been in this space for some time. I would say since 2017-18. Austria is starting to come up with some of these projects, but we see them popping up in the rest of the world. And I think this is something that we should really think about. Sludge is not just sludge anymore. The digital technologies increase the transparency of processes and therefore enabling real-time monitoring and control. So for example, installing sensors for pH, dissolved oxygen, turbidity, flow or level devices, and integrating the measured values into an IoT ecosystem allows the operators to gain immediate insights into source water quality, for example, or plant performance, hence enabling quick decisions and therefore early issue detection. Also, what we think is getting more and more critical is the monitoring of asset health status. 20 years ago, we don't hear of operators being particularly concerned about that, but of late, this is becoming really crucial, also because of the variety of digital technologies that are available today. And this is important because it directly impacts the measured values, giving an indication of the status of the asset long before a failure takes place. So this helps to reduce any unplanned downtime and ensures also legislative compliance. So if we think of data as a fuel for digital tools, then if the fuel is dirty, the engine misfires. So when data is inaccurate, incomplete, or even unreliable, it can lead to incorrect process control decisions. For example, overdosing or underdosing, false alarms or missed faults. So this could then lead to a waste of time and resources on the operator's point of view, or non-compliance, and worse, inefficient operations. So this could mean higher energy use and therefore higher OPEX. So ensuring high data quality is crucial. And in my opinion, we can do this in a variety of ways, but I think the top three important ways would be: one, using really high quality instruments from a reputable and established supplier. I cannot stress this enough, because in the space that we are in the instrumentation business, you get thousands, literally thousands of suppliers for flow meters and pH sensors and all that. So how can an operator decide which one to choose? And the second one is maintaining the instruments according to the supplier's protocol is really essential, because regular calibration and verification ensures that the health of the particular asset is kept at a high level, and that impacts obviously on data quality. And lastly, and I think this is really a very basic topic, and that is the installation of the sensors. Placement matters. Poor installations can cause inaccurate and reliable readings, and sometimes the fault is then put on the sensor itself, but the sensor can be working perfectly. It's just the location where it is. It's not correct. So that is extremely crucial. We have authorized service engineers who are highly skilled and trained in where and how this installation should take place. For instance, if the sensor should be placed at a certain 45-degree angle in order to prevent air bubbles from accumulating on the surface and therefore giving the operator inaccurate readings, for instance, or maybe placing the flow meter too close to an area where there's too much turbulence. So these are areas that our service engineers can advise our customers on. In my opinion, all the industrial water markets have a need for innovative digital solutions. But I think what is really critical are industries that have regulatory pressure as well as constraints of resources. I would say, in my opinion, the food and beverage industry. In my opinion, AI-powered predictive operations, where AI and machine learning algorithms continuously learn from operational data to optimize treatment processes. We've seen it happening already with companies, startup companies, tech companies that are able to provide use cases and successes. We've seen really good benefits for the operators. For instance, the reduction of energy consumption, fewer operator interventions, reduced maintenance efforts on assets in the plant. It's on the growth path right now, but I really see this as part of the business in the next, in fact, 5 years. And coming back to the topic of water reuse at the beginning of the interview, I think advanced water reuse and resource recovery will gain momentum in the next few years. For example, in my opinion, I think it is possible for advanced technologies like forward osmosis or, the membrane bioreactors to work in tandem with AI to make sure that the processes are much more efficiently managed. For instance, the commercial recovery of phosphorus from ash, it has always been piloted. We hear of a few projects sprouting up here and there, but I think this might be more commercially viable in the next few years. And lastly, moving away from technology, I see a strategic shift from asset ownership to service-based models, such as measurement as a service or water as a service, whatever way you call it. I think this concept challenges the traditional status quo and will become more attractive.